So just a little firing terminology. Bisque firing is the first firing. So when we are done with our pieces and they're on the drying shelf and they're completely dry, I'm going to put them in the bisque firing kiln and I'm going to fire them to a low temperature. That temperature that we're going to fire it to is cone 05. And as we get along, we'll sort of get into what that means. But basically, that'll remove the chemical water from the clay, making it porous but durable. So we can pick it up without having to worry about it cracking within our fingers. Glaze firing is the second firing, where we paint a coat of glaze, which will melt and adhere to the surface, creating a fully sealed piece. So a little bit about glaze. Glaze is essentially a form of like liquid glass almost. Now, it's like liquid glass and clay body combined. So that's where we go back to that initial formula of alumina, silica, and water. Silica is how they make glass. Silica is the base chemical for glass. So when we make a clay body, we're going to use more alumina than silica. When we make a glaze, we're going to use more silica than alumina. And you say, wait, but doesn't that make it a clay body? Yes. So there are very few differences between a clay body and a glaze. The only difference is the amount of silica to alumina. So if we've got more silica, it's a glaze. If we've got more alumina, it's a clay body. And that glaze is going to melt into a glass coating on the surface. Now, when we do glaze, we want to think about things like, do I want it glossy? Do I want it matte? And is this a functional piece? The purpose of glaze is to create a nice, thick coating on your piece so that it will not absorb water. Why would we maybe not want to absorb water and be porous? Maybe because it's a good breeding ground for bacteria. So that glassy coating on the inside of your bowl or your cup is there to prevent your clay from becoming a really great, surface for mold to grow on or bacteria. And that's a really important thing to remember. And that's why a lot of like the insides of certain pottery, especially functional things like cups and bowls, are white. And that's so we can see when it's dirty, so that we can really get in there and clean it. And that glassy coating is going to allow us to clean it properly. So vitrification, from the Latin word vitrea, meaning to form into a fully non-crystalline glass. This is important. The clay will no longer be porous. It is fully fired. When we talk about temperatures for clays, we're going to use terms called cones. This is how ceramic artists track temperature inside of the kiln. It refers to a physical form of the cone, which has been formulated to melt at a specific temperature. So I'm going to go ahead and stop sharing for just a minute. I should have grabbed it. That's my bad. So give me 1 second. How's everybody doing? Are we hanging in there? Yeah? Okay, so when we talk about a cone, we're talking about these. So these are how we measure temperature in the ceramic world. These are chemically formulated to melt at a specific temperature. This one's going to melt at 015. That's a pretty low temp, but basically it's a cone. And what we'll do is we'll stack a couple up and we'll watch through a little peephole like this. And when this melts, it'll bend over, it'll start to curve a little bit, which will let us know that, hey, it's reached that temperature. So we'll have one that is exactly the same temperature, one that's a little less, and one that's a little more. So if we see that the one that we need to reach is bent over, we're going to go ahead and turn off the kiln, shut everything up, because it's done. But we won't know it's done until these have bent. All right, so this is what we call a pyrometric cone chart. It looks like a lot of numbers. It is a lot of numbers. Unless you really want to get into clay, this is just, you just need to know a little bit about what we're doing. So over here on the left-hand side, and I would say if you are going to be an art education major and you've got like, maybe you want to do like a little bit of ceramics in your classroom, this would be important to know, because chances are you're going to have an old kiln with a kiln sitter, and these are going to be good references. So notice it goes from 022 to 14. How does that work? So anytime you see a 0, we're going to pretend like that's like a negative number. So zeros are going to be on the lower end of the temperature spectrum, and anything that's just the number itself will be on the higher end of the spectrum. So if something is cone 015, it's going to be at 1382 degrees Fahrenheit versus cone 05, which is what we're going to bisque to. So write that down. Cone 05 is our bisque temperature. It's going to be 1870 degrees. Now, that's a big difference. But notice how when we get up here to these higher numbers, that big gap becomes sequentially smaller. And that's got to do with quartz inversion and certain chemical factors. But we are going to fire in this class. We're going to bisque fire to 05, and we're going to glaze fire to cone 5. So when we do our functional, or when we do our throwing, we're going to glaze fire to cone 5 and bisque fire to 05. Now our other pieces, our slab molds, we're going to actually do at a lower temperature because our terracotta clay doesn't go that high. Our terracotta really matures fully at about 02. So we're going to go to 05 for our low fire clay, our earthenware, our Longhorn Red, and then I'm going to actually push it a little farther, and I'm going to take it to 02. I'm going to take it to 2, so that way it's fully vitrified for you, and that way it'll hold a little bit of water. Now, the one thing about terracotta that's different than other clay bodies is it actually never fully vitrifies. However, if we were to take it hotter, it would melt into a big liquid puddle. So important cones to remember. I already said it, but let's just re-emphasize. We bisque fire to 05. That's 1870 degrees Fahrenheit. This is going to remove the chemical water and allow our pots to be porous and absorb glaze. So we'll be able to paint on our glassy coating at this point. We glaze fire to a varied temperature range, as most clays will be different. So one clay may not work at a certain temperature as another clay. Low fire, the range is 20 to 2. Mid-range is 1 to 6. High fire is 5 to 11. These are the terms we use to reference how hot we're going to go. So most of our stuff will stay within the low fire to mid-range zone. It's time to stack the kiln. All right, so this is a gas kiln. We have one a little bit like that, except ours is sort of boxy shaped. We're going to be primarily living in a electric kiln for the most part. So when it's time to load the kiln, you will need 2 things: kiln posts and kiln shelves. So if you can probably guess, these are the posts and these are the shelves. So when we stack these things, we have to think about physics, because we're going to put a bunch of heat inside of there. So kiln shelves will be the sturdiest when the posts are set up in sets of 3. That's sort of important to remember, and it's not just clay. You know, when you build things that have 3 points of pressure will be more sturdy than things that have 4 points of pressure. And it's something to do with the way that the material pulls. So if I were to put like 4 posts on one of these shelves, it would be more likely to bow here in the center. So when I stack this shelf, I'm going to put one here on the left, I'm going to put one here on the right, I'm going to put one on the other side, right in the middle, and I will match that all the way up from the bottom. And that's going to allow that pressure to be equally distributed. Glazing, oh my gosh, it's chemistry. Why is glaze important? We already sort of touched on it a little bit, but basically glaze is important because it provides a barrier between the naked clay body and food, allowing your dishware to be cleaned easily. It prevents bacteria from settling in your cup and keeps you healthy. The glass will also reinforce your work, providing an extra layer of strength and durability. So it'll allow you to drop that cup a couple times before it shatters. So glaze basics. Glaze can be almost identical to clay bodies. The biggest difference being that glaze will contain more silica, which is what we call a glass former. So this means that glazes are almost like painting liquid glass on your piece. Glass, however, melts at a really high temperature, much higher than clay, and we need our glass to melt to our pot. So chemically, we have to balance that glass to however high that clay will go, which means we need to add something called a flux. If you remember, I said iron is a flux. Iron's going to lower that temperature. A flux is an ingredient that is put into place to lower the temperature of a glaze. And often, if the ratio of glass former to flux isn't balanced to fit the clay body, your glaze will actually exhibit a few flaws. Some of the flaws are pretty, but some of them are like a little annoying. So let's sort of get into those. Glaze flaws, a few issues to watch out for. So crazing is when your glass cracks, like a shattered window all around your pot. And you can actually, crazing is kind of funny because you can actually hear it while it happens. So we pull a piece of pottery out of the kiln and we put it on the shelf, and you're just sitting there, you know, next to your pottery, and all of a sudden you hear just these little ting, 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 and your pot is making that sound because it's crazing, because the glass did not fit the clay body. The clay body did not shrink enough for the glass. Crawling is when the glaze pulls away from itself and the pot. Crawling happens sometimes when you leave a big spot of moisture while you're glazing and there was no room for that glaze to adhere to your bisque piece. And when we get into glazing, we'll go back over this, so don't stress if we don't get it down perfectly now. Metal release. Now this is the one we really want to work for, and I actually challenge each of you to sort of test this out on your stuff at home. And the way we test it is very, very simple. So when the glass isn't fully sealed, when that glaze isn't fully sealed, it will release toxic chemicals. This is why they sometimes recall, you know, certain products after they send them out. So what you can do to sort of test this is get a lemon, something with an acid in it, and just squeeze it into the bottom of your cup and let it just hang out for like a day or two. If you see that lemon juice turn any color other than cloudy, then your cup is leaching chemicals.